to make to this your attention. And yes, Animesh, I believe you can continue with the introduction of Professor Halim.
Thank you, Omid, and I welcome you all for this workshop. And today we have with us Professor Halim Yanikomeroglu as a keynote speaker. The title of his keynote is 6G and Beyond 6G HAPS Networks, an evolution with a revolutionary impact. Professor Yanikomeroglu doesn't need any introduction as he is well known in the wireless communication community. However, as a program chair of this workshop, it is my pleasure to say a few words about him. Professor Halim is a professor in Department of Systems and Communication Engineering, Carleton University, Canada. His group's primary research domain is wireless communication and networks. His research group has made contribution to 4G and 5G wireless technologies, with current focus on the aerial and satellite networks for the 6G and beyond 6G era. His group at Carleton constitutes an international hub for research and innovation in wireless communication systems and network. He has co-authored IEEE papers with faculty members in 80+ universities in 20 countries and industry researchers in 10 countries. Dr. Yanikomeroglu is an IEEE fellow and have received several awards in his research, teaching, and service, most recently the IEEE Communication Society Frederick W. Ellersick Prize in 2021. Without further ado, please join me in welcoming Professor Halim Yanikomeroglu. Professor Halim, floor is yours now.
Excuse me, Professor Halim, you are mute, so please unmute yourself.
Thank you. I also welcome everyone to the HAPS Networks workshop. Just let me go to my slide deck. Once again, Animesh, Omid, thank you very much. I should mention that what I will be presenting today is a product of joint work with quite a number of people within my group as well as my collaborators. Some of you are in the audience. It will be quite many people if I start naming names. Therefore, a generic thank you for everyone who has contributed to this area. And hopefully today's workshop will result in further collaborations. In the title, we see 6G beyond 6G, although I should remark that network architecture evolution does not often jive well with the generations of wireless networks. What I meant by putting 6G and beyond 6G is we do not have immediate applications in mind. Rather, we are trying to look forward to 2030s, even beyond that, as it will become apparent in the presentation. And the subtitle, HAPS has revolutionary impact. That is something I will argue very strongly, and hopefully we will have discussion on that. However, it is an evolutionary concept. That is, it is a natural evolution of the architecture. It doesn't mean that we have to put aside our decades-old know-how and start again. No, this is just a natural evolution, yet it is disruptive because its impact is revolutionary. This is what I mean. My promotional 2 slides. I'm at Carleton University, although the campus is closed. I come once in a while. I know all the Carleton people missed our beautiful campus. Not too many people would know the following 2 points: that in Canada, the only university which features a Bachelor of Engineering in Communications Engineering is Carleton University. That area is a strength of the university. And it is not accidental that in global ranking, according to subject areas, in this year's list, in the field of telecommunications engineering, Carleton ranks number 19 in the world. We are very proud of that achievement. As mentioned earlier, every year we organize a number of 6G workshops. Each workshop has a theme. Last year we had 4 of them: faster than Nyquist signaling, a technology that we have been working also at Carleton University. Satellite mega constellations, again, a research stream here at Carleton. AI, ML, and analytics for networks. And we concluded the last academic year a few months ago with a 6G physical layer festival. And today we have the first workshop of the new academic year. It is not confirmed yet, but in the fall, we would like to have the second edition of Faster Than Nyquist Signaling Workshop. If you are not in my workshops and seminars mailing list, my email is there. Just drop me an email. Now, today I will be talking very cheerfully about high altitude platform systems. And some people, surprisingly, from the satellite community, get a little bit uneasy, as if I am pushing forward HAPS as an alternative to satellites. That is absolutely not the case. Actually, I am a big believer in satellite networks. At Carleton, we have a separate research group in addition to HAPS group. Professor Güneş Karabulut Kurt is with us today from Polytechnic Montreal. My satellite communications work is done jointly with her. We have a rather large team, and you see the research streams here: handoff management, routing, as well as later inter-satellite links. So once again, today I will not be talking about satellite networks, or I will actually be talking about satellite networks to position high altitude platform station networks. But it is not my intention to favor one or another. They are different. They have different place. And as necessary, we can come back to this topic in the discussion part. So I will start with some clarifications. In my view, there are some misconceptions about HAPS systems. And then to better position HAPS systems, I will talk about high throughput satellites. And at the end, I will present a vertical, what I call a vertical heterogeneous network architecture, VHETNet, for integrated communications, computing, and so many other things, including caching, sensing, navigation, and positioning. As a matter of fact, there are a number of presentations later today on various aspects of this emerging network architecture. Well, NTN, non-terrestrial networks, this is a term used in 3GPP circles. And what it means is integrated terrestrial aerial satellite network. The term integrated is important because satellite networks have been in existence for a very long time, decades, but they are not integrated with the terrestrial network. And integration is less than straightforward. In this view graph, you see a very rich network with the terrestrial part and the aerial part, and then the space part. In the aerial part, there are drones, UAVs. These are at altitude, say around 100, 200, or several hundred meters. Today, I will not talk about them to focus on HAPS exclusively. However, I have to, I guess, remark that as a very positive development about 2 years ago, or precisely January 2020, 3GPP in the context of Release 17 endorsed the idea of UXMB, that is a UAV as a base station or as a relay. UAVs obviously can also be UEs like cargo drones. And then let me go to the space part. There are several layers of satellites, LEOs and MEOs and GEOs. But what is less known in the generic community, although since you are here, I hope that you have some background in HAPS, High Altitude Platform Station is one of the best kept secrets of wireless network architecture, and that is the discussion topic today. Here is the formal definition. Although this definition will be revised, I will mention that in 2023. So this definition is coming from 1997, 25 years old. ITU defined it as a station on an object at an altitude of 20 to 50 kilometers at a specified nominal fixed point relative to the Earth. A few remarks. One important distinguishing feature of HAPS in comparison to satellites is that they are non-orbiting. They are fixed with respect to an Earth observer, either fixed or almost fixed. It depends on the aircraft type, to be precise. I'll come to that in a moment. ITU definition allows altitudes 20 to 50 kilometers, but all the projects so far that I am aware of have concentrated on around 20 kilometers. That should be noted as well. Now here we see three types of HAPS systems. Perhaps the most rudimentary one is a balloon, helium balloon, for instance. That was the case for the high-profile Loon project of Google, which got terminated earlier this year after a decade of trials and some limited service. The other two more advanced aircraft types, one of them is an airship, a blimp, an aerostat. It is lighter than aircraft. A good example of this is Thales project, Protobus. It is like a Zeppelin. And this might come in the fixed-wing aircraft format. It can be even manned, but again, all the projects I am aware are unmanned systems. If it's a fixed-wing aircraft, it is not literally stationary, but it makes either circular moves with a radius of 1 or few kilometers or figure-8 move. And actually, therefore, with ITU strict definition, fixed-wing aircraft is not a HAPS, interestingly. But ITU is relaxing this definition in the next World Radio Conference to include fixed-wing aircraft as well in the HAPS definition. So here are a few high-profile projects like Airbus's Zephyr. And the next two are more interesting because they are supported by operators. This is a humongous development in the history of HAPS systems. HAPS has a history of very long time, decades, but never operators have been involved heavily. So in this first part of my talk, I'm emphasizing this change. Now 3GPP, ITU, and operators are looking at HAPS concept in a more progressive way. For instance, Softbank is a major Japanese operator. It has a subsidiary, HAPS Mobile. They have this Sun Glider concept. And UKTelekom has also a subsidiary, an aircraft designed by C&C, and the payload designed by SPL of Cambridge Consulting. I guess the aircraft is designed by SPL and the payload is designed by Cambridge consultants. Yeah, ITU has been the biggest pusher pushing factor for HAPS systems. Since 1990s, ITU has been dedicating spectrum, and this is not harmonized spectrum, standalone spectrum for HAPS systems. This is one of the recent editions of ITU News magazine right after the last World Radio Conference at Sharm el-Sheikh in December 2019. Once again, HAPS played a big role, and it is argued that there is even more spectrum need for HAPS systems, so on and so forth. However, ITU's, let us say, support has been both a blessing, for sure a big blessing, but a little bit of a curse as well. The reason is that ITU has been coming to this area from rural and remote coverage perspective. It is well known that in rural areas, the economics does not make much sense to have a terrestrial network because there are few customers. The situation is worse from that viewpoint in remote areas. And how do you provide coverage, especially in the earlier days? Satellite constellations either didn't exist or were not successful. So HAPS is conceived as an intermediate solution, if I may say, between satellites and terrestrial networks, in particular, cost-efficient solution. Therefore, since the beginning, I should say, until now or until very recently, HAPS has been almost equated with rural and remote coverage. Now, this is not good news today, in my view. Certainly, HAPS might have a great role to play in rural and remote coverage. However, keep in mind that there were disruptive changes in that area. Starlink came pretty much out of nowhere just 3 years ago, and now it is a big success in rural and remote coverage. So it is a big, actually, competitor in that sense to the HAPS technology there. And the business case has been rather small in rural and remote, although HAPS is still low cost with respect to terrestrial, but again, a profitable business case, I think companies couldn't come up with. So that is the kind of curse part. As I will argue, the potential of HAPS is much, much, much bigger than rural and remote. And today, I will be focusing on almost exclusively HAPS systems for urban areas, for megacities, smart societies. And if we can make HAPS work in that context, due to economies of scale, they can be implemented in rural and remote as well. So that is my viewpoint. When we look at ITU, just bear with me. I hope I will not bore you with some terms and so on, but this kind of political and structural discussion is important. I would like to look at this integrated terrestrial aerial satellite networks paradigm from ITU and 3GPP perspective. It is important to note that in ITU, there are two divisions from the perspective of this discussion. One of them is working party 5C and then working party 5D. These are different ecosystems in ITU. Their meetings are different. They feed each other, but they are different groups. Working party 5C is in charge of what is called fixed wireless systems, including satellites and HAPS. And then 5D is for IMT, that is International Mobile Telecommunication Systems. Among other things, in the context of today's discussion, it is cellular, mobile networks. So 3G, 4G, that kind of networks we are talking about. Now, there has been a very important, rather recent, a few years ago, development, especially in World Radio Conference 2019. ITU separated HAPS into two branches. Actually, the second one, it is coming with a new name, although it is not very popular in the 3GPP community. It is called HIPS, meaning HAPS as an IMT base station. So in moving forward in ITU terminology, there is HAPS. This is like a pseudo satellite, and it is with satellite discussions. And it is air interface is different, frequency bands are different than the cellular networks. And then there is an harmonized with the cellular concept. It is HAPS, because now HAPS is considered as an IMT base station. I find this as an important evolution of viewpoints, because this is what I have been arguing for a number of years now, that HAPS has similarities to satellite networks, but it has distinctions as well. Now, let us move to 3GPP. Interestingly, as soon as GSM became a big success, early 90s, our community, because I'm coming from more the 3GPP side, our community has been talking about integration. You will find papers, even textbooks, on the subject matter from 1990s. And the prediction would be the next generation, the next G, we would have integrated networks. If you look at the papers from 1990s, again, it was predicted that 3G, we would have integrated satellite terrestrial network. Pretty much it means that a mobile device can quickly make handoff between two networks, that's at the least, or even they are using the same air interface. It didn't happen in 3G, didn't happen in 4G, didn't happen in 5G. However, starting very recently, this discussion has intensified quite a bit in 3GPP, and now there is a bigger push, bigger than ever, in the context of upcoming 6G standardization, which is just around the corner, mid this decade, maybe 2015, 2016, maybe release 2021, we will call it 6G. So very soon, and let us see whether this integration will happen the way it is perceived. So something that I have been feeling very uncomfortable about, and I always mentioned this in my HAPS presentations, in 3GPP, NTN is a rather recent term. We have been seeing this in recent releases, but when they say NTN, even today, up to last month, actually last month, something big happened. I'll just show it in the next slide. So NTN meant satellites and HAPS together, similar to earlier ITU vision. And in 3GPP documents, you will also see another heading, separate UAS, unmanned aerial systems. Clearly, this is UAV as a base station and as a user as well. And I also would like to note that in 3GPP terminology, HIPS is not a common term, but whenever 3GPP says HAPS, they actually mean HIPS, because 3GPP is on mobile networks, and therefore HAPS has to be an IMT base station. So keep that in mind. When you look at 3GPP documents, you will see reference to HAPS, but in the more recent ITU technology, they say HAPS, they mean HIPS. So what happened last month is that for the first time, in the context of starting release 18 discussions, there is a new heading separate than NTN and UAS with the title HAPS. So HAPS is a standalone discussion item. It is not bundled with satellites. And this is important because HAPS looks like a macro base station in some ways. It looks like a satellite in some other ways. Actually, it looks like a LEO and also a GEO. But the important point is it has distinct characteristics and it has to be studied, investigated, explored separately. Let us look at the ITU and 3GPP timeline. I will start with ITU. As mentioned earlier, in World Radio Conference 97, HAPS came with the definition and a strong concept. Every 3-4 years, there's a World Radio Conference, mainly around spectrum discussions. As mentioned earlier, there have been spectrum allocation to HAPS systems. But discussion actually changed quite a bit, meaning intensified around the time frame of the very last World Radio Conference at Sharm el-Sheikh, 2019, the famous Resolution 247. Their HAPS definition is recognized. Now HAPS might be harmonized with the IMT network, and it was put as an agenda item for the subsequent World Radio Conference, which will be held in 2023. Some new bands below 2.6 gigahertz will be discussed to be allocated to an harmonized HAPS terrestrial network. So what is next? Well, just in 2 years, we will have World Radio Conference. Actually, as we speak, several workshops are taking place around the world. One important WRC workshop will happen in October, and through World Wireless World Research Forum, WWRF, Carleton University will make a contribution in favor of HAPS or HIPS systems. So you may wish to watch out the developments because ITU is important in this discussion. ITU defines the rules of the game, and based on that, 3GPP takes action. So most of us perhaps here are following 3GPP, but 3GPP has to follow ITU. Therefore, ITU is important. So something interesting will happen there, most likely. One of them I just mentioned, HAPS definition is being relaxed so that fixed-wing aircraft, which make circular moves, will be included. And fixed service, meaning that satellite, now HAPS concept in ITU is moving from satellite domain to IMT domain, that is working party 5C to 5D. And I mentioned harmonized bands. And then something also very interesting. Now, first time, ITU will talk about inter-HIPS links, very much like inter-satellite communications. So we are for the first time starting to talk about a transport network in the air. This discussion has been happening for a decade in the satellite side, constellations, laser inter-satellite links, terabits per second, all optical transport network. Now this discussion is coming to the HAPS domain. So inter-HIPS links and HIPS to satellite links will be part of the discussion. Well, ITU, just a note since we have started this discussion, ITU does not involve free space optical. It is mainly for RF. So in this red highlight, it will be an RF discussion, but I think it is just a natural extension in the research community to consider FSO as well as an enabler. Let us move to 3GPP. More formally, NTN discussion in 3GPP started about 4 years ago with this document, technical report 38.811. This report became available within release 15 about a year and a half ago. And this big development that happened last week of June, first week of July, there was release 18 workshop. And just to put a context, release 18 studies will start in January 2020, and it will release 18 is supposed to be released in fall 2023. But the agenda, the study items of release 18, and this is 5G evolution, are being determined. There was this workshop a month ago. There will be another workshop in September. And as I said, as a big step, now HAPS is separate than NT, that is separate than satellite networks. There were a number of interesting contributions from China and mainly from Japan, because now Softbank is a big promoter of HAPS systems. Well, 3GPP, what will happen is, I assume, at some point, whether it is release 20 or 21, it's a little bit speculative, but we will call it 6G a few releases later. So it will be interesting to see how this discussion will evolve. I would like to say a couple of words about the term integrated. It is sometimes used a bit lightly. So first of all, let us separate terrestrial satellite integration and terrestrial aerial integration. As I will show in the upcoming slides, in the near future, and by the way, in the satellite domain, near future is like a decade, because satellites have very long life. If it is a GEO, it is almost 20 years. If it is a LEO, it might be 5 to 7 years. So once you design the system and you launch your system, you can't upgrade it very quickly. So it is there operational for a while. So this decade, in my view, it is a little bit difficult. I will discuss this a little bit more, for a terminal with the same air interface to reach LEO systems. I think this will happen maybe in the next decade. So if that is not the case, then the integration scenarios that we are talking about, they don't have to be a tight integration. Therefore, I use the term light integration. For instance, in a rural community, there might be a 5G base station. It can collect the signals in the access site. Then it can be backhauled through a LEO network, but that doesn't require a tight integration. So integration in that sense is a good word in terrestrial satellite case, but not necessarily, a little bit misleading in the terrestrial aerial, because we can do better than even the tightest integration. Because when you say integration, it means that you have two separate networks, and after the fact, after the networks are operational, you are trying to integrate them. And that is the case for satellites. Now, Starlink is, as we speak, the network is already up and operational, and it is growing. And it makes sense to try to integrate that with cellular. But when it comes to HAPS in particular, we can design it as part of the terrestrial network. Now, I am aware that there is a semantics issue. Terrestrial and aerial node semantically doesn't make sense. Therefore, in my publications, I use the term VHETNet, vertical heterogeneous network. Obviously, HETNet means small cells and macro cells. Since 4G days, this is an important concept. And now HETNet is evolving vertically to include high altitude platform stations as well. By the way, in my talk, when I say HAPS, I mean HIPS in the ITU terminology, right? So what are the salient features of the vertical HETNet? I don't have two different networks in mind. This is from the very start, one single network with different base stations. So in addition to two-tier small base station, macro base station, I used in recent publications, for instance, super macro base station as the third layer or tier. Moreover, this network is not for connectivity alone, but it is for computing, caching, sensing, so on and so forth. Actually, just let me open a parenthesis here. This is a very big paradigm shift in 6G. 5G, the paradigm shift was vertical industries. So connectivity up to 4G has been pretty much to the smartphone, 5G connectivity to all other industries, but 6G, it is more than connectivity. It is integrated communication, sensing, computing, navigation. In that framework, HAPS is very fitting because it can enable those, as I will allude to. Also, as I mentioned, we have urban deployments have in mind first and foremost. Therefore, this jives well with smart cities and smart societies paradigms. And also we are considering beyond 5G technologies, in addition to 5G, like native AI, ML, or reconfigurable intelligent surfaces. There will be talks on these subjects later today. So the framework is clear. This super macro base station is native. It is just an order of magnitude bigger. You have the small base station, an order of magnitude bigger macro base station, another order of magnitude bigger, you have the super macro base station. The first time we used the term VHATNet in a journal paper was IEEE Transactions on Wireless Communications paper from 1.5 years ago. And then more consistently, we started using the term. For instance, there is an earlier TWC paper from this year. Our concept paper on HAPS as a super macro base station came earlier this year as a communications magazine paper with our partners from industry as co-authors. And just a few months ago, this paper, A Vision and Framework for the High Altitude Platform Station Networks of the Future, came out with a number of co-authors. Professor Güneş Kurt was the lead co-author. She is with us now. This is, I think, 51-page paper in double column format. It is the most comprehensive HAPS paper that I'm aware in the literature. What we mean, just as a snapshot, I will unpack this figure later, but either as a single HAPS or a cluster or a constellation of HAPS on top of a big city, whether it is Toronto, London, or Istanbul, or Shanghai, millions of people down being served. HAPS or the cluster of HAPS have different beams at different coverage, serving ground users, aerial users, hotspots, backhauling, you name it. Let us move to high throughput satellites. I should mention that maybe two other important developments in the HAPS area. HAPS Alliance have been formed about 2 years ago. It is important in the sense that both operators and aerospace industry, first time they came and now working together, because these two are two different ecosystems. And very recently, in the last few months, two important white papers came out. You can search them. One of them, wireless mobile, or mobile world, sorry, mobile world. And just literally a few weeks ago, GSMA, it is, of course, a forum for operators. All the big operators in the world are members. They came up with a very forward-looking HAPS vision paper. You can search them. I think they are very informative. So this is an indication that 3-decade-old HAPS discussion is now at a new level. Operators are in the business because operators have had to be convinced to deploy the networks, and now they seem to be actually leading the discussions. What happened in satellite communications is that a move took place from broadcasting to broadband communications, internet, basically. So satellite networks needed much more capacity, and the enabling technology in the last decade was multibeams, multiple beams. So capacity comes from multiple beams. These type of satellites are referred to as HTS, high throughput satellites, or very high throughput satellites, ultra high throughput satellites. I'll just stick to the term HTS. And a state of the art is CASAT. It is a GEO. I have to mention that conventionally, when people say HTS, they have a GEO in mind. The reason is that GEOs are big, at least an order of magnitude bigger than LEOs. So they are huge. Here there is an artist's rendition of state-of-the-art CASAT. It has, very large transponders. Transponders might be in the order of 5 meters in diameter, and they can realize these huge hundreds of beams. I'm saying state-of-the-art, but this CASAT was launched actually a decade ago. However, it will be operational throughout this decade as well. Therefore, it is the state-of-the-art in that sense. As you see, it is big. It is payload, that is the electronics and photonics part, is 1 ton, and it is payload consumes 11 kilowatt. By the way, just for comparison, this is how much a 5G base station consumes for comparison. And all this power is obviously obtained from sun with very large solar panels. And this one has 82 beams, and you see it is targeting Western Europe and Northern Africa. And collectively, across these 82 beams, the capacity of one CASAT, a GeoSat, is 90 gigabits per second. Keep in mind that this is from 10 years ago, and throughout last decade, satellite literature has been very active studying very high number of beams in the context of GEOs. As the number of beams increase, the diameter of beam width becomes narrower, as low as 0.3 degrees. And an interesting pointer for people who know less about satellites is that due to the topology—
Recording in progress.
Yes, due to topology, all these beams have very similar path laws. Therefore, universal frequency reuse is not possible, at least with today's technology. So interestingly, these multi-beam satellites use like GSM type of frequency planning. The norm is color 4, as you see. If, for instance, there are 400 beams with reuse factor 1/4, you have 100 times reuse. Now, what is coming up? Something very interesting. Satellite networks, as I am saying, I am a very big fan of satellite networks. I do a lot of research in that area, not for today, but what I am saying is that that area is very active, and the next generation, just for and if you could basically mute people from the participants list, please. Thank you. So this Viasat 3 is coming up. It will be deployed maybe next year, maybe the year after. It is a GEO now with more than or around 1,000 beams. That is a first, 1,000 beams. It is a GEO once again, and across those beams, a capacity of 1 terabits per second will be possible. So first time, satellite industry is talking about terabits per second. Now, as expected, that very high number of beam technology is now moving to the LEOs. Everyone is talking about Starlink, but actually something very interesting, another satellite project is the Canadian Telesat's Lightspeed constellation, which will be a constellation of 300 LEOs. The first launch will happen in less than 2 years. These are actually bigger LEOs. Actually, I should probably put the next slide here, SpaceX as a comparison. For instance, Telesat, their altitude are higher than SpaceX altitudes, as you see, and it is also bigger, 700 kilogram in comparison to 260 kilogram of Starlink satellites. And keep in mind that this is not the payload. Payload is a fraction of the launch mass. Their operation is 10 years. Very important point, they will have inter-satellite links, so the transport network we have been talking about. Now, individual satellites have 675 beams. Once again, this is very forward-looking for a LEO network. This number of satellites, beams, we have been talking about GEOs a decade ago. And each satellite will have a capacity 50 gigabits per second. So collectively in the network, we are talking about 15 terabits per second. In comparison to band pipe satellites, this Telesat one employs full onboard signal processing with even routing functionalities. I already mentioned Starlink. It is capacity per satellite is a bit more modest, but the number of satellites is huge, as you know. Just the mere launching at the current speed, that is 2 launches per month with 60 satellites per launch, it will take 29 years to launch 42,000 satellites. So some disruptive things should happen in the launching to put those 42,000 in the next 10 years. Now, I would like to bring up this very nice paper written by European Space Agency researchers, Future Technologies for Very High Throughput Satellite Systems. In the next 2 slides, I will go through them. Look at the use cases articulated for near future. Keep in mind that in this terminology, near future is this decade, 2020s. Communications on the move, meaning airplanes, trains, for instance, trunking, backhauling, IoT, wide area IoT. But the thing is, as they correctly and honestly say, scholarly, this doesn't require tight integration. In the medium term, integration of satellite-based technologies within 5G is expected to happen mainly at ground segment level. That is, we are again talking about 2 different air interface, but just at the ground station, access and backhaul, it is integrated there. Now, as mentioned, there is big emphasis on very high number of beams, beam widths of less than 2 degrees are studied, are being built, and low Earth orbit, very low Earth orbit satellites, since they might use higher frequency bands, these beams might be created by smaller transponders. So it is mentioned that more than 1,000 beam satellites should be possible for first GSO systems, that is geostationary orbit, but it is just a matter of time to see this many beams in LEO systems. There is a parenthetical remark, but might be important, and that is these multi-beams technology is actually different than massive MIMO. In massive MIMO, each antenna is controlled with a separate RF chain. Spot beams are like sectors. So we are talking about base station with 1,000 different sectors. And finally, laser inter-satellite links is also a game changer because now we have a network in the space. To sum up this section of the talk, in the terrestrial satellite integration dynamics, so many parties are talking, including people like me from academia. We are often over cheerful, go, 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 let us make an all integrated network. IEEE is mainly kind of led by academics, so they are kind of together. But if we go to especially ITU and agencies, I think their papers are, just to be frank with you, more realistic and down to earth, and they more clearly outline that this tight integration, unless, so here is the demarcation point, unless we are talking about a mobile unit, without any modification talking to satellites, then a tight integration is really not necessary in the near future. All the use cases with light integration at the ground station is sufficient. And satellite industry is putting up their network without really betting on 5G or 6G. And it is also important to note that what we call as satellite industry is not monolithic. Actually, there are two major camps. There are the legacy players like Telesat and so on, the known big players, but then there are newcomers from data, from IP, internet industry, like Amazon and so on. And especially these ones, they don't seem to be too much concerned about ITU and 3GPP and so on. They just put up their network. Basically, integration is not necessarily critical in their roadmap in the near future. So I already mentioned my prediction is that light integration is sufficient in 2020s. That is the 5G era. This is mainly about backhauling, for instance. In some cases, there might be dual connectivity with two different air interfaces. For instance, a vehicle. A vehicle might be in suburban areas outside the terrestrial coverage, and it can just switch to satellite network. But the interesting part will likely happen next decade. It is a 6G era, and there we are again talking about a device reaching directly to satellite. Now, I have to open a big parenthesis here because there is a rather recent development. Some of you might be following that. There is a new company called AST Science, and they have a project, Space Mobile. And that is now funded by some big operators, including Rakuten and so on. And they are claiming that within this decade, they will have a constellation, first around the equator, and then gradually the entire globe. And it will be just an unmodified cell phone reaching a satellite network, a 5G or 6G phone. Now, how is this possible? Obviously, everything boils down to link budget. So their technology is they want to make geo-sized satellites in LEO orbit. So huge satellites, an order of magnitude bigger than Starlink satellites, but not at geo altitude, at LEO altitude. In that way, the antenna gains are huge, and then link budget might work for, let us say, video browsing through a LEO network. So I'm moving now to HAPS systems. I only have about 15 minutes left. Maybe even before I start, I just mention a very big there are two major misconceptions about HAPS systems. As soon as you talk about a one network, a vertical headnet, small, macro, and HAPS base station, people say, oh, you are talking about a base station 20 kilometers? That is far, far away. Not really. Let us make a very simple link budget calculation. HAPS has the advantage that most of the time it is line of sight, propagation exponent, path loss exponent 2. Compare a macro base station 1 kilometer away with a path loss of 3 and a HAPS system with a path loss of 2. And let us compare the path loss. 20,000 square divided by 1,000 to the cube. So 20,000 square is 4 times 10 to the 8 divided by 1,000 to the cube, that is 10 to the 9. HAPS has less path loss than a macro base station, unless macro base station is in line of sight. So HAPS has actually HAPS's path loss due to calculation is comparable even to a small base station if that small base station has a path loss exponent of 4, because 100 meters to the 4 is 10 to the 8. That is the HAPS path loss. So path loss is not necessarily more than the terrestrial network. Secondly, delay. People would say, oh, delay, 20 kilometers, my goodness. That's not the case. 300 kilometers is 1 millisecond at the speed of light. So 40 kilometers is about 1/8 of a millisecond, 130 microseconds. Nothing, absolutely nothing for pretty much any and every application you can think of, because the delay really in the network is in buffering, scheduling, segmenting, congestion, all other things. The propagation delay of HAPS will not impact anything. Actually, overall delay in the HAPS system will be less than the terrestrial network. Why? Because in the terrestrial network, often reaching microbase station is not enough. You have to go deep in the network, multiple hops, and each hop, each router and switch will incur a lot of delay, more than delay as the propagation delay. But HAPS is one shot, go up and down, big bird's eye view area. So it is there for advantages. I will go through quickly a few HAPS projects. There is this Protobus by Thales Alenia. This aircraft is important because it is big, it is payload. Currently in the current project is 0.5 ton, but it might be more in the future. It has a history. The launch has been delayed several times, and they are predicting now mid this decade. This is another high-profile project with a target launch again mid this decade. Softbank of Japan. It is a glider. And then arguably one of the most advanced projects, this is the UK plus Deutsche Telekom joint venture. It is relying, so this is what I have been telling. These multiple beams started with HTS of GEO, they came to LEO, now they are coming to HAPS. So this, at least initiative, is betting on almost 500 individual steerable beams. It is a huge antenna, 120 kilograms, and collectively can have more than 100 gigabits per second. Once again, target mid this decade. Now let us look at the history of HAPS systems. Let me skip this slide. It has a very rich and interesting history. Canada played a very important role in 1980s, but that is for perhaps another talk. Most recent history has been Google Loon. That will be a balloon, helium balloon with a LTE payload. From the other projects I mentioned, this is very rudimentary, but it was a very good start. It was a proof of concept. It was operational in few cases, but not integrated. Google Loon's operations was mainly, in the desert, you have video streaming from the Loon. Also, I have to acknowledge that Google, in this course of last decade, developed and demonstrated first balloon-to-balloon free space optical communications. That is not easy when these balloons are moving, and tracking and acquisition is very important in those networks. So we had a lot of, as a community, know-how from Google Loon. So this decade, there are lots of fixed-wing aircraft and airship projects, much advanced aircrafts, and I anticipate that still operations will start in rural and remote with less reliance on integration. But the real interesting story is next decade, 6G and beyond 6G era. These are the dense urban deployments, and we have very large airships in the size of a football field, International Space Station, for instance, that type of size. And it is, as I will allude a little bit more connectivity, communication, navigation, and all of that towards smart cities and societies of the future. Now, ultramassive MIMO is a very important technology for 5G and 6G. We can create lots of beams, and facades of buildings can create this ultramassive MIMO structure. But the catch is that as soon as you put the ultramassive MIMO in the city clutter, you are affected by blockage and shadowing. You might have very high capacity and put that capacity on top of a big building. Those beams do not reach to the street. They don't see the street due to the clutter. So there is this big practical problem for ultramassive MIMO. Well, you can put it in a plain open area in rural areas, but there's no need for capacity in those areas to start with. I think you are sensing where I am heading to. Why not having this ultramassive MIMO or a huge number of dynamic beams at a HAPS? Well, it is already conceived anyway by some of the concepts and companies I have mentioned. So a ball of super high capacity in the air. So it is the capacity of easily 10 macro base stations, if not more. And with these maneuverable and dynamic beams, you give that to different users, different hotspots or bigger spots. If I have been working on agile access architecture since my graduate studies, 1990, more than 30 years. And my research has been on and off on the agility of the architecture. I cannot think of an architecture more agile, more flexible than this one. So no waste of the capacity. There is no supply-demand mismatch. That is, you put your network, but then it stays idle because the demand does not appear at that point there. On some other part, there is an unpredictable demand, but you don't have much network density there. Then why don't you centralize your capacity in the sky? And of course, I am not talking this as an alternative to the terrestrial network. It is all one network with terrestrial part and aerial part. Let us do a back of the envelope calculation. What if I go to millimeter wave and have about 10 gigahertz of bandwidth? And what if I have spectral efficiency modest, 16 QAM, 4 bits per second per hertz? And what if I put 1,000 beams? People are already building 500 beam. I just say, okay, 1,000 beams. And then with a reuse of 1/4, 250 reuse possibility. Just multiply, you are at 10 terabits per second. A mind-boggling 10 terabits per second. This is a rate even beyond 6G. And I know that it will look a bit outrageous, but I would like to make this thought experiment. What if we have super advanced antenna architectures? And if it is not one HAPS in a big city like Istanbul or London, UK, or Shanghai, put a cluster of HAPS, 4 of them at the corners of the cities. And let us say collectively you have 10,000 beams. In that case, you would have a mind-boggling 100 terabits per second centralized capacity, truly unprecedented in wireless discussions. Obviously, there are lots of issues. What will be the backhauling and so on and so forth? We can discuss those separately. But I wanted to make at this point this calculation. Well, I'm just my time has ended, but if I can steal 10 minutes from my presentation, I will just quickly go through the slides. So here are, so if we are talking about 0.2 beam width at 20 kilometers, This makes a hot spot of 70 meters. Interesting. A HAPS with a beam can track a vehicle or a group of vehicles. And these beams might expand or shrink based on the need. So as you see, we have a very dynamic situation with different beam widths. This is the key enabler in next generation HAPS. So I covered most of the things in this slide. It is possible to achieve terabits or even tens of terabits per second. Backhauling will rely on opportunistically to free space optical whenever it is possible. And HAPS can operate at different bands. In outdoors, it might be possible to go up to the lower end of terahertz communications, D band. And to penetrate indoors, it can also operate below 6 gigahertz as well. Applications are very, very, very many. Pretty much any application, except for maybe things like indoor factory floor and so on, which will require extremely low sub-millisecond latency. Except for some very special cases, for sure outdoors, any application you have in mind seems to be possible. And then I will go through some of those applications in the next 8 minutes. My group's journey started HAPS with envisioning an urban application. And this study goes back to 2016-17. Our paper came out in January 2018. The study was done jointly with Kaust, my colleague and friend, Mohammed Selim Alouni. FSO-based, vertical front wall, back wall for small cells, basically. So small cells is important paradigm, but backhauling is difficult. We said that don't worry, put lasers or a hybrid RF FSO and send this backhauling trunk upward, and then they are aggregated at the HAPS and then moved to a gateway. This was one of the very first ideas in the literature at the time for, again, urban settings. The paper has been received very well, and this year ICC last week, it got the IEEE Fred Ellersig Prize. HAPS systems will play a very important role in aerial highways. Cargo drones, for instance, is a big paradigm shift by itself. We have 2 magazine papers accepted. All the papers are available either in Explore or Archive, those that will appear in Explore. One of them is in Com magazine, the other is Vehicular Technology magazine. And we are articulating how HAPS, as the holder of UAV traffic management, can facilitate aerial traffic. And this is important. Imagine an urban area and let us say an Alibaba or Amazon warehouse, super warehouse, and drones are going up from there. It is like, you know, truck after truck after truck. There will be aerial highways if it goes 20 kilometers. How do you give coverage to those aerial highways? If you put a HAPS with, it is again bird's eye view of a large area without any issues, without any handoff, this can give the required coverage. Now I am changing the discussion to something very interesting. Reflection through Loon. This has been conceptualized back in 1940s. And in 1950s, NASA with Bell Labs developed this project ECHO. It is the first metallic balloon, and 2 ECHOs were launched in 1960 and 1964. These are totally passive reflectors, 30 meters in diameter, and at a LEO altitude. And based on this success, a late 60s there was a constellation. Now most people forget about that. A constellation of metallic balloons. This project was called PAGEOS, Passive Geodetic Earth Orbiting Satellite, at an altitude of 4,000 kilometers, a constellation of 46 satellites. This is mainly for positioning, actually, the earlier GPS system, if I may say. Now, these are 1950s or 60s, 70 or 60 years later, we are thinking of putting smart surfaces, another type of reflector. But these type of reflectors are much more intelligent than these types. These are entirely passive, but these ones are, as you know, the RSS technology. They can be phased aligned. Therefore, the signals are basically constructively put together. So much better performance, not at 4,000 kilometers, it is just at 20 kilometers. One of the speeches this afternoon would be on that. We are, for instance, thinking of having a 100 by 100, 10,000 meters square plate, RSS plate, hanging from a Zeppelin. Now you will say that, why do you do that instead of, not necessarily instead of, but given that we have these spot beams, it is exploration for energy viewpoint, from because this energy is a very big issue for HAPS systems, and reconfigurable intelligent surfaces consume very little energy. And HAPS might have both technologies. We had our concept paper, Safwan will present that this afternoon in Communications magazine earlier this year, and we have just recently accepted paper in Open Journal of Communication Society doing a detailed link budget analysis. Another work which is under review in Communications magazine is intelligent transportation systems through these transcontinental highways. For instance, in Canada, from coast to coast, we have this highway. Most of the Canadian population is around this highway. If you have a chain of, let us say, 50 HAPS nodes, you can basically do a lot of things in Canada. Another talk today, I shouldn't get into that too much, especially given that I consumed my time. A lot of edge computing and data offloading is possible with HAPS. Keep in mind that delay is not an issue. The delay 20 kilometers up and down 40 kilometers is nothing, 1/8 of a millisecond. Therefore, we are conceptualizing a new level of edge computing. There is fog computing at small base station, edge computing at macro base station, then cloud computing at the core. We might have something like border computing at HAPS base station. She has a paper under review at she ran at IEEE Transactions on Wireless Communications, and another paper is cooking. I don't want to get into too much details because she will be presenting these ideas. And one of the very final concepts, this one-shot aggregation and broadcast may result in lots of opportunities in federated learning, compressed sensing, and digital twins. Take federated learning as a case study, for instance. Rather than small cells and macro cells do federated learning, collect, aggregate information, then pass them for a higher layer in a tree architecture, we can do that in one shot with a HAPS architecture, because HAPS can see a sufficiently large coverage area. Yet another very interesting concept is in recent releases of 3GPP, in particular 17, now GPS type of functionalities which are performed by satellites are being done, or there is an opportunity to do that with within the cellular network localization. But although the air interface provides this opportunity, in reality, outdoor environments do not have a sufficient number of anchor nodes. This very recent study shows that in a metropolitan area, most locations have only 1 or 2 anchor nodes, which is not sufficient. But now imagine, once again, an urban area like Toronto, put 2 HAPS at 2 sides of the city. So suddenly almost all outdoor locations have additional 2 anchors. And then if you can have 2 other terrestrial anchors, you can make a 4 anchor triangulation and have the sub-meter level of accuracy. We have a team working on localization, navigation, and positioning. That is HAPS systems acting as super anchors, either a standalone system or helping the terrestrial system, or even integrated with a satellite network for a much better localization, navigation, and positioning. Let us keep in mind that this will be very important for drones as well, especially at some point, I don't know whether it is 2030s or 40s, if these drones move around within the city cluster as well. Well, this advanced network with HAPS elements, even satellite elements, terrestrial elements, obviously it is extremely complex. And if we think about software-defined networking, network function virtualization, these type of inter-domain, end-to-end functionalities, it is clear that AI and ML will have a big role to play. We have a recent paper with our collaborators in industry in Wireless Communications magazine, a vision for self-evolving network management for future intelligent vertical head nets. And self-evolving network is the next level, or the next level after SON, self-evolving, self-organizing network. So we have self-organizing network in 5G if we have kind of one type of network. But if we have a network of networks and end-to-end operation goes through several networks with several ecosystems, then we call it a self-evolving network. So HAPS has very many interesting features. It is very scalable. You can start with 1 or 2 HAPS in a very cost-effective manner. It is evolutionary. The very geostationary nature creates opportunities closer to Earth. Direct connection to handheld device is possible, and there is no even legislation type of issues that we see in the satellite world. Therefore, again, HAPS networks come with enormous opportunities. And in conclusion, I would like to once again go back to what I said early on. What is HAPS? Is it like a GEO, LEO, macro base station? Well, it has a much higher, if I compare with a GEO, it has a much higher area capacity. Path loss is incomparably lower, and latency is also incomparably lower, like 3 orders of magnitudes. With LEO, similar advantages with GEO, but at a more modest scale, still at a free space path loss, 28 dB advantage in path loss with respect to LEO. Latency is again more than an order of magnitude less. It doesn't orbit, of course, and it is real estate is much bigger. Therefore, we can put tremendous antenna architectures which wouldn't be possible in a LEO. And then comparison to macro base station, it is line of sight most of the time. Bird's eye view of a large area creates one-shot connection opportunities. And as I mentioned earlier, path loss is in many cases comparable to a macro base station, or even it might be lower. basically, most things, but not all, most things that you can do with satellites, you can do with HAPS systems, perhaps even better. And many things, or most things, you can do with macro base stations, you can do with HAPS base stations as well, perhaps even better. And actually, there might be even use cases and functionalities which would be difficult, if not impossible, with geos and macros. They can be facilitated with HAPS networks. I would like to remark in conclusion that this really doesn't mean that there is no need for satellite networks. That is not the point. Satellite networks are there. They create other opportunities. For instance, something that HAPS cannot do, but satellite network is coming very strongly. I will not get into this. We have a separate line of research, many papers either published or coming up. This round trip time, backhaul, long backhaul links, satellite networks creates substantial advantage in reduction the round trip time, and this might have applications in, for instance, in bidding in stock markets, so on and so forth. If you are interested, you can check some of these papers. I was having a conversation with Tim Tozer and David Grace. Tim is now an emeritus professor. They were among the very first people in academia, in HAPS systems. This paper 20 years ago is still one of the most important papers in this domain. And Tim was saying, well, I will just say it in my own words. There are basically three major challenges for a HAPS network. Part of them is ICT related, and I discussed them today. And it seems that they can be handled by technology. But another big challenge is energy. All these functionalities, especially as HAPS becomes more and more complex, where will that energy coming from? And sun energy may not be sufficient for more advanced HAPS architectures. And perhaps the biggest challenge, interestingly, is endurance. HAPS is much lower than a satellite, but having a high endurance HAPS as an aircraft is more difficult than satellite, and still it seems that this endurance issue is the major bottleneck. This is my last slide. This is what we are envisioning towards 2040s, even 50s, an integrated and all integrated network for urban and other use cases, a cluster of HAPS on top of a big city. This is will have thousands of beams, and it is a distributed ultra-massive MIMO. It has data and caching functionalities as well. It is backhauled in a variety of ways, RF and FSO, to ground stations and to the satellite transport network. I don't want to get into too much to the energy part, but the upcoming HAPS systems might need energy in the order of 5G base station. And this seems to be okay with just getting from the sun and then storing in batteries. But if we go further with bigger functionalities in mind, tens of terabits per second, then you will need much more energy. And battery technologies are advancing rapidly. And one possibility that we are thinking of as a concept, since this is a huge infrastructure, special aircraft, drones of special sort, might regularly go and bring new energy, new batteries, and take the older ones down. And this might help to the energy system. Well, once again, thank you very much to all my collaborators. We have very many colleagues working on at Carleton. I have a website, also, sorry, YouTube channel. I will post this presentation there as well. Lots of material. and Carleton University, after the pandemic, is starting the visiting scholars, in-person visiting scholars program in January 2022. Hopefully, this workshop will create new opportunities. So I stop sharing my screen, and I would suggest that I'm just looking at the program. The next part was supposed to start now. How about we, Animesh, do you think it will be okay if we make only about a 5-minute discussion now? And then we can have this discussion also in the Q&A before the lunch break, so that this will not too much disrupt the program.
I think this is a perfect plan. So if any of you have any questions, please unmute yourself, and Professor Halim is here to answer your question.
Any questions from or comments from the audience? Then I will go to chat, perhaps, Animesh. I see there are 2 messages. Let me, okay, so, yes.
So shall I read it for you?
I can read it, actually. Doesn't the 3GPP NTN scope include HAPS, which are not HAPS UE on HAPS? Well, basically, if we are talking about a HAPS system, this is the older viewpoint of ITU for rural and remote coverage at separate bands, at not IMT bands, not 5G band, not 6G band. This is less of an interest for 3GPP. 3GPP are for mobile systems. Then we are talking about a different ecosystem. So that is really what I mean. And so far, HAPS projects have been projects of the aerospace industry, not 3GPP industry. And that is the reason why we haven't seen any successful large-scale HAPS deployment. Why? Because operators have not been in. These were separate, again, entities, isolated projects, and there is no economies of scale. There is no strong business case. For operators to come in, it has to be within IMT, that is the 3G, 4G, 5G, 6G bands. So finally, ITU realized that they still keep the original HAPS definition, because ITU still believes, and probably they are correct, that HAPS as a standalone network, non-integrated standalone network, it might have a role in, offshore air rigs and, mines and so many other applications in rural and remote. So that is now what is referred to as HAPS or kind of umbrella HAPS. But the more interesting part is HIPS in the ITU terminology, that is HAPS as an IMT base station. Now, whenever we see HAPS in 3GPP documents, unless otherwise specified, 3GPP community means HAPS within IMT bands, right? As a mobile network. Like 3GPP, they have, you see satellite, but satellite 3GPP is not in satellite business. What they mean is integration. It's a different ecosystem, a different network, different bands. So from 3GPP's scope, HAPS is meaningful when it is HIPS. It is, I know, a little bit confusing. However, just to make it short, in 3GPP documents, when they say HAPS, they mean HIPS. Any other comment? I see a comment here as well. Okay, well, any literature, there are quite a number of papers, and actually look at the papers of the presenters today. Actually, Google the presenters, you will see a lot of paper in their websites and in in Explore, including my group's work. I have put up quite a number of white papers. Since 2021, January, at least in my group, we had about 8 magazine papers published on or accepted or under review. Also, this communication surveys and tutorial paper came up recently. It's quite extensive. So lots of literature coming up. So I will then leave it there, but we can continue if time permits in the other Q&A sessions. I will be present. Thank you very much, Animesh.
Yeah, thank you, Professor Halim, for your excellent and informative keynote talk.